Hello everyone. This will be our last topic. Last topic is moments of inertia. And we need, of course, yung mastery natin sa pag-solve ng centroids, which was our last topic, no? Last topic. Yung pag-solve ng centroid or center of gravity of a certain area, a composite area. And we need that dito sa topic natin ngayon na moments of inertia. So ano ang moment of inertia? Okay, medyo ang application nito ay ano sa design subjects natin and pati na rin sa ano sa hydraulics, ano pa? Sa strength of materials yan and sa mga design subjects natin. Doon natin i-apply yung itong moment of inertia. So sa subject natin, we are just going to discuss how to solve for the moment of inertia of a certain section or a certain area. Okay? So ano ba itong moment of inertia? So let's just try to read the definition of moment of inertia nandun sa module natin. So in the application of mechanics, if a load is distributed continuously over an area on which they act, the computation of the loading distribution about an axis perpendicular to the area will involve a quantity called moment of inertia or the second moment of area. Okay? So I know you're familiar with this term na yung moment of inertia because this is one of the applications of integral calculus, no? Yung pag-solve ng second moment of area. Okay? And I think na-discuss naman yata. Nasa latter part na yun ng integral calculus, no? Yung application. So maraming applications ang integral calculus sa civil engineering. Now, medyo mahirap siyang ano, no? Medyo technical yung definition, but yung moment of inertia is somehow it measures the efficiency of a certain section, a certain area, okay, against bending stresses, against bending. No, let's try for example. Let's say for example, meron tayong beam. Ito ko na lang isulat. Ay, may space sa taas. For example, we have a beam here. May beam, simply supported beam. Pag sinabing simply supported beam, it is supported by a hinge, one end, and then a roller at the other end of the beam. So, let's say for example, meron tayong concentrated load sa may gitna. Load F. So, ang behavior ng beam, of course, ay magbe-bend yan. Bend. Gilo ka na matan. So, mag-bend yung beam pag ganun. So, this is just an exaggerated deformation of the beam. So, the beam would bend downwards, no? Kapag, of course, downwards yung application ng load. So, definitely the beam would bend downwards also. Okay? So, yung moment of inertia is a measure, sabi ko kanina, measure of efficiency ng cross-section ng beam against bending. Now, for example, yung beam natin is rectangular. So, rectangular. So, pwedeng, which is usually the case na for concrete structures, yung beam natin, columns and beams are usually rectangular. So, we have base, height. Okay? And then, meron din tayong, so, ang configuration is pwedeng ganito, yung base natin. So, ganyan yung kanya, configuration niya. Or pwedeng flat. Ganyan. Yung beam. Is the base, is the height. So, which section is more capable of resisting bending? No. So, anong section ang mas capable ng resisting bending? Okay. So, obviously, ito, no. Itong section na to ang mas nagre-resist ng bending kasi mas mahaba itong height niya, no? Ganyan yung configuration niya, yung placement niya dun sa may supports. Okay? So this would the obvious naman, no? Ito mas mahirap siyang mag-bend compared dito, no? Ito. Mas mahirap mag-bend ito compared dito. Okay? So ganun, pag mas mataas yung moment of inertia ng isang section, mas malaki yung efficiency niya, okay, against bending. Okay, bending. All right? So ganun. So for rectangular beams, for rectangular sections, the moment of inertia is centroidal moment of inertia, just for this discussion. IXO is equal to BH cube all over 12. No. So, tingnan nyo, yung height niya is cube yan. Okay. So, obviously, kapag ito yung height, mas maliit yung height natin compared sa base, mas maliit yung kanyang moment of inertia. Okay. Pag mas malaki yung height niya, mas malaki naman yung moment of inertia natin. So, it measures na, yung moment of inertia, it measures the efficiency of the cross section, okay, against bending. Okay, against bending yan. Okay? So, i-review natin yung moment of inertia from integral calculus. Again, don't worry. Sa mga takot sa calculus kagaya ko, takot ako sa calculus eh. Pero masaya naman, no? Masaya. Yung, especially kapag ina-apply mo na yung calculus sa engineering. Ayan, so ito yung formula natin to solve for the moment of inertia. So, ang notation natin is Ix or Iy, no? Depende sa axis kung saan natin sinosolve yung moment of inertia, yung baseline natin to solve for the moment of inertia. So, moment of inertia is sometimes called the second moment of area. Second moment of area. So, yung area natin magmo-moment ka about a certain axis. Okay. So ito yung formula natin. Ito yung formula natin for moment of inertia. So, ito yung ating illustration. Ano? Illustrate natin. So, to solve for the moment of inertia of this particular area relative to x-axis, ito. Okay. X-axis, ito yung x-axis. Okay. So, yung dA natin, dA times yung distance niya ng centroid niya from the x-axis. Ayan. Squared yan, squared. Okay. So, ibig sabihin, dalawang beses mo i-multiply yung distance na yan dun sa differential area. That's why it's called second moment of area. Tama. Area. Ayan. So, yung distance niya is y, of course. So, twice natin i-multiply yung distance na yan dun sa differential area. Okay? And then, lahat ng yan, so yung integral calculus, so isa-sum up yung application ng integral calculus, so lahat ng differential area, so may limits yan, so of course. So, i-sum up natin lahat yan. That's the idea of integration, ano? Sum up natin lahat yan. Lahat ng dA times y squared. That would be the moment of inertia of this area about the x-axis. So, we call that Ix, I sub x. Okay? Ganon din naman sa Iy. So, yung differential area natin. So, and then yung centroid ng differential area papunta doon sa y-axis, I should say, y-axis. So, that's the x coordinate of yung centroid nito papunta doon from the y-axis. No? Okay? So, that's it. So, dA times twice rin multiply yung x, so x squared na siya. So, that's how we compute for the value of Iy, or the moment of inertia of this area, the whole area about the y-axis. Okay? So, that's the concept. Okay? And we also have this one, polar moment of inertia. So, i-add lang natin yun. Dalawa. Ix and Iy. Polar moment of inertia. Itong polar moment of inertia naman would be applied kapag yung structure natin or structural element is subjected to rotation or torsion. Ito naman, itong moment of inertia, rectangular moment of inertia ay ginagamit natin yan for bending. Okay, so bending. You will meet this one sa next sa higher subject ninyo, fluid mechanics or hydraulics, and then mechanics of deformable bodies. Ayan. So, i-apply nyo ito doon kasi you will be dealing with stresses later on. And yung mga different types of stresses would include bending stresses or flexural stresses. So, yung nai-stress yung ito. So, nai-stress yung beam natin due to bending. And then, another is the torsional stress. Ayan, torsion. Torsion is yung twisting. Pag nag-twist naman yung structural element, so it experiences torsional stress. Okay? And we need these values now to compute for the stresses, yung moment of inertia. Okay? Rectangular moment of inertia and polar moment of inertia. Okay? So we will just focus on the computation of the rectangular moment of inertia kasi yung polar moment of inertia is just the sum of the two lang naman. Ano? Okay? So, ganun natin kino-compute yung moment of inertia using integral calculus. So, since, don't worry, may mga derived formulas na tayo, okay, ng moment of inertia ng mga regular na sections such as rectangle, triangle, so may circle, quarter circle, mga ganun. Meron tayong derived, no? Derived yun using integral calculus. Now, another concept that we need to understand is the parallel axis theorem for an area. Sometimes in other books, they call this one the transfer formula. Okay? Kasi itong transfer formula natin, ito. Okay? Ito yung derivation. Okay, that means itong parallel axis theorem now to compute for the moment of inertia of a certain area relative to an axis. Okay, relative to an axis. We're going to use the parallel axis theorem, which okay, let's continue. Continue interruption. So the moment of inertia of an area about any axis, so take note of this, any axis that is parallel to the centroidal axis, okay, can be determined by the parallel axis theorem. So which means that if we know the moment of inertia of a certain area, the centroidal moment of inertia. Ano ba yung centroidal moment of inertia? Kapag, for example, we have a rectangle, ano? Ito yung centroid niya. So, ito yung axis natin sa may centroid. So, let's say this is XO, YO. So, if we know the moment of inertia relative to this centroidal axis, we can solve the moment of inertia of this area relative to a certain parallel axis. So, for example, ito yung ating x-axis, y-axis. No? We can solve for IX and IY. Okay. IX and IY of the section if we know the centroidal moment of inertia of this section. So we call this one the IXO, IYO. IXO is for centroidal moment of inertia about x-axis, centroidal axis, x, no? And then IYO naman yung moment of inertia of this section about the centroidal y-axis. Ito yung centroid natin, C. Okay? So we can solve the moment of inertia of this section, no, about a certain parallel axis using the parallel axis theorem. Or we call this one the transfer formula. Ang tawag natin dyan. Okay? So, no need to memorize a lot of formulas, para i-solve yung moment of inertia about a certain axis. Ang kailangan lang natin is i-memorize yung formula ng yung centroidal moment of inertia. Okay? Formula ng centroidal moment of inertia ng isang section. And then If we are to solve for the, sorry, the moment of inertia of that section to a certain axis, then we are going to use the parallel axis theorem or the transfer formula. Okay, ito yung transfer formula natin. Okay, so I sub O or whichever na parallel axis, pwedeng Ix yan or Iy, is equal to the centroidal moment of inertia of the section plus AD squared. So area ng section times D. Ano yung D na yan? Distance between the center of the section, okay, from the axis, parallel axis. Now, so this is, okay, dy, this is dx in this example. Ano? So, for example, sorry, andun pala, this is dy. So this is dy. So if you want to solve for IXO, no, so Ix pala, sorry. So, the distance between the centroid to x-axis, ito yun. Yan yung d squared dyan. Ito naman yung kapag, if you want to solve for the moment of inertia of this section using the centroidal moment of inertia of this section, no? Ito yung d natin from the y-axis. Okay? So, d squared. So, kailangan lang natin is yung area ng section and then the distance between the centroid to the axis being considered. Alright? So, ganun lang kasimple. So, ang memorize lang natin is the centroidal moment of inertia. Now, if the problem requires us to solve the moment of inertia of that section to a certain axis, then we're going to use the transfer formula or the parallel axis theorem. Okay? And don't worry, we're going to illustrate that later on sa mga problems. Okay? Okay, I think we're good. So, yun lang naman ang kailangan nating malaman. Ito pala yung derivation. May mga derivations pala dito. So, para ma-recall natin yung integral calculus. So, for rectangular sections, ito, moment of inertia for rectangle with respect to its base and with respect to its centroidal x-axis. Ito. With respect to base, or that is x-axis in this case. So, Ix, so yung differential area natin, no? That is dy times b. So, ito yung b, ano? And this is dy. So, the differential area is just the product of b and dy. And since b is constant all throughout, no? Constant naman yan. So, pwede natin ilagay dun sa labas ng ito, anong tawag dito? Integral sign. Yan. And then, so, equal lang natin. So, dy times b times y squared. Ito na yun. Okay, ilabas natin yung b and then, ang limits natin of course ay yung from, sorry, 0 to h. So, 0 dito sa may origin to h here sa height ng rectangle. Okay, and we will be arriving with this formula. So, for the moment of inertia of this rectangular section about the x-axis dito, hindi sa centroid, dito sa may base niya, is bh cubed all over 3. But usually, okay, oftentimes, what we are concerned about is the centroidal moment of inertia. Yung moment of inertia niya dito sa may centroidal axis. So, this is xo, yo. So, what we're going to do, we're going to use the parallel axis theorem to solve for the centroidal moment of inertia about the centroidal axis, no, of this section. So, ito yung formula natin kanina. So, we're solving for Ix, Ixo. So, Ixo ang hinahanap natin. Okay, yung centroidal moment of inertia. So, which means we're going to manipulate this equation. Okay, ito na yung i-transfer natin Ixo sa right side and then we'll be arriving with this equation. Okay. So, yan na. So, the centroidal moment of inertia about the centroidal x-axis is for all rectangular sections would be bh cubed over 12. So, bh cubed over 12. Ito naman for triangle. Ito yung derivation niya. Meron pa bang ibang? Ito naman for circle. Yung derivation. Okay. The same concept, of course. Same concept. Okay, and itong radius of gyration, wag na lang muna yun. So, focus muna tayo sa sa pag-solve ng moment of inertia. I'm sorry. Okay, so meron tayong summary ng moment of inertia dito. So, ang kailangan lang natin is ma-memorize yung centroidal moment of inertia ng bawat section. So, in case, yung sabi ko kanina po ulit-ulit, in case we are required to solve for the moment of inertia of the section relative to a certain axis, hindi dun sa centroidal axis, we are just going to use the transfer formula or the parallel axis theorem. Okay? So ito yung mga centroidal moment of inertia, IXO, IYO. So memorize lang natin ito For rectangle, BH cube over 12. Ito IYO na baliktad lang yung bilang magiging cube kasi magiging base niya ay yung ito na. Okay? And triangle, circle, we also have semicircle. Ito yung mga derived na formulas natin using integral calculus. Quarter circle. Ano pa ba? Wala na. So we're going now to illustrate how to solve for the moment of inertia of built-up sections, composite na sections natin sa next video na lang. So example tayo. Okay? So kapag rectangle, triangle, circle, ito lang naman. Ang mahirap lang kapag composite or combined yung sections natin, then we have to compute yung ito. Kapag ito regular shapes, direct substitution sa formula. Pero kapag composite, we have to solve for the moment of inertia of the composite figure. So succeeding na videos, you will be solving the moment of inertia of composite figures. Okay, so composite sections or areas. All right. Okay, so see you sa next na video.